All right, let's get started. So this talk is going to be really quick. I'm Marc, I'm from Fertig. We're going to run Kotlin as many times as we can in 15 minutes. Let's go. This is the code we're going to run. Is prime, the code really doesn't matter, so we're just going to call is prime in many different contexts. And every time we run it, we're going to hit the bell. And then I got that from Duncan. So Duncan is also here at the conference. He's not giving a talk, but you should see his talks. Like pairing with Duncan is amazing. So here we have the code. We have a multi-platform project. Here's the common module. We have the isPrime function. Let's start with the first one. So we have the JVM module here. We have the main.kt. We can run this here, running it on the JVM. And there we go. We ran primes. First one. Maybe someone can count, so I don't have to. Okay. Okay. Then let's go to Android. So let's go to Android. Let's select Android here. Let's run it. So here we have the Android device on the right-hand side. Let's run it. Does it run? Yes, it runs. Here we have 71 is a prime. Indeed, we have Kotlin running a second time. And actually, this is, actually two, because here we can go to the main activity, and of course we have compose previews. Let's stop the emulator so it gives us a little bit more performance, which we'll need for Xcode to run. So here we have previews. We have the code running here. 72 is not a prime, so let's actually run the Kotlin code another time. That's already 3 times. So, okay, going to iOS. This is really cool. We have the iOS app. It depends on the common module. So we can select iOS app here in Android Studio, which I think is just really amazing. So we're going to run that. Bam, here's the iOS simulator. It's running. Bam. OK, kill the iOS simulator. Xcode. Here we have Xcode, and we have SwiftUI previews. We can change the code here. So indeed, we can run Kotlin in SwiftUI previews. That's another time. OK, let's close Xcode. Good. So with that, OK, now I will be much more relaxed. OK, perfect. So we have 5 ones. Let's actually, OK, so you can run Kotlin, of course, in Gradle. So here we have a build Gradle file, which basically takes input directory. We have different files which are named like numbers. So we're going to copy only the files which are prime. So here we call the isPrime function, which we have here in the Gradle module. So I have the README here. We can run that. Bam. Let's see if it runs. And it's run, so let's actually see. So we have the build folder here, we have the primes folder here, so we have prime numbers. We copied the files for the prime numbers. Okay, let's close that one. Okay, next up is the playground. So really cool, even if you're on the mobile phone or on the one, if you have internet, you can run Kotlin. So here we have the Kotlin playground, which I think is really cool. So here, let's actually open it up a little bit. Increase the font size. So here we have the isPrimes online on play.kotlin lang.org. We're going to run that, get some prime numbers, and there we go. It ran. OK, very cool. Also here, note you can switch also backends. You can switch to JS, WASM. You can run that as well. I'm not going to count that because it's still the Kotlin playground. But I think it's pretty amazing. You can just play with the different technologies online on the Kotlin playground, which is kind of cool. Woo! OK. Let's go back. OK, next one up is macOS. So with Kotlin native, you can compile macOS binaries. So you can actually compile programs like you would, for example, like a C or C++ or like a Rust program. So here we're calling the common code. It's basically just the main function. We already compiled the isPrime file, so we can actually run that in the terminal. And there we go. We have the primes running. Kotlin native for macOS. Go. OK. And also, Kotlin native is really cool because you can also compile it for Linux and so on. But I have a Mac, so what do? So here we have the main.kt. We can actually use Docker to run the executable. So here I'm going to ask Docker just to run in Ubuntu. And here we have the file, which we just import from the local directory. We're going to run that. And there we go. We have Kotlin native, running in Linux, running a Docker image on a Mac. That's a... There we go. OK, now we go to the next one. Also, this is really cool. So here we have, in the build directory, We have the binary, so here we have the isprime.exe file. How do we do that on the Mac? I mean, we could run the whole Windows, but we don't need to. Luckily for Linux and Mac, there's a tool called Wine, which you can just install, and then you can run that. So we're going to run that one here so we don't get the warnings. There we go, the Windows exe file with Kotlin native code running on a, in Wine on a Mac. There we go, we have primes. Did somebody count? I lost track, sorry. Okay, let's go to the next one. Scratch files. Really useful tool in IntelliJ. If you want a scratch file, you just type Command-Shift-N, or you just type double-shift, and then you say scratch file. So we create a new scratch file with Kotlin in this case. So here we have Kotlin, and let's just copy, paste the thing from the README. So here we have, we're calling the isPrime function, so let's go back to the scratch file. Here we go. It's not finding the isPrime function because we need to select a class module. As you can see, I have many modules here in this project, which is basically killing myself on stage. So let's actually type JVM main. Let's use this one. There we can find the isPrime function. We're going to run that. Running Kotlin in a scratch file. Let's see if we can do it. Oh yeah, we got the result here. So bam, running in the scratch file. Okay. Now also, I mean, if you worked with Gradle, you noticed like the KTS extension, but you can also run KTS files, like script files, on your machine locally. You can just do a KTS file, run your code here, and then you can right-click. I love the IDE integration. This is like a celebration of all, like Kotlin, like where we can run Kotlin. So here we have the Kotlin script file running on the local machine. And you can also call that just directly from the terminal, which is also really cool. Just type Kotlin. So if you installed the Kotlin native tooling, command line tooling, then you can just type Kotlin and then the file, and then it's going to run. But then I wondered, actually, OK, so here we have the same KTS file, but can we actually run that as an executable on the shell? And actually you can. So this is weird because usually this sign is like not allowed in Kotlin, but if you type this at the very first line, it's actually as a comment. So that means that we basically say, hey, we use Kotlin. So like a bash script, we can make this file executable now. So let's actually open this in the terminal. Open in terminal, open. I need to type directly, open in terminal. There we go. OK, now we type / to execute it, primes.kts. And the Kotlin tool will come over. It's going to run the code. There we go. OK, we have some prime numbers. And what's really cool also about the native tooling, let's actually open up the terminal again. With native tooling, you can also just, if you want an expression, like for example, you have like a really hard math equation, like this one, then you can type that in. Sorry, I need to copy, paste correctly. OK, there we go. 6.7 times 7 is like 42. That's running. OK, so you can also type a little bit more things, but you can also run the Kotlin REPL, which is an actually, let's decrease the font size here a little bit so you can see this better. So here we're going to execute the Kotlin REPL, which is basically a thing that you can use to just dynamically run the code. So here we go. We will copy over all the things here. So from the prime.kts file, so the thing that we just ran, and we're going to type it here, so we can just type Kotlin here. There we go. The same code running in the Kotlin REPL on the terminal. OK. So next run. As you can see, I used to forget to show the REPL, so this is why I have the file here. So here we have Kotlin JS, which is really cool. So here we have JS, so it depends on the common module. So it depends. It will create two different variants, like browser and Node.js. You can run it in the browser, and you can run it on the command line with Node. So this is really cool. So we're gonna also love the IDE integration. You just hit the run button. JS browser development run. So we're going to open the browser. There we go. OK, now we're going to open the console. There we have the primes running in the browser. And then we're going to stop the Gradle task, run it again, but this time with Node on the command line. So we're going to run it. And there we go. We have the primes here on the command line with Node. And this is basically compiling Kotlin to JS. So this is using JavaScript. And I noticed that actually, if you find primes with JavaScript, that's actually kind of slow. But we have WebAssembly, so let's actually use that one. So here we have WebAssembly, and here we actually have 3 targets. There's a new one. I'm going to go into that pretty soon. So here we have the target browser. We have the target Node.js. It's going to look the same, but it's going to be executed much faster. So we're going to run the same thing here. So we have the web main target, which is basically for browser and Node. So here we're going to run in the browser again, but now the WebAssembly finding primes faster. So here we go. We have the terminal. If it opens up, here we have the primes running with WASM in the browser, and you can use Compose, of course. Compose Multiplatform also uses this technology to run in the browser, so it's much faster. And now we're actually going to stop that again, run it again in Node.js locally. So again, WebAssembly, but now running locally, so also pretty fast. So we have it in Node with WebAssembly running on our machine. And now this is a really cool technology. So with WASI, we can actually use system interfaces. So here we have a system interface which we're going to use, which is defined like, so it's called clock time get. So we're going to get the system clock from WebAssembly and call the isPrime function on it. Why not? This is using some weird, memory allocator. So because it's very close to, the Y, like with C, we actually do some pointer arithmetic here. I didn't come up with the code. It's online, so this was really helpful. But now we're actually going to repeat 1,000 times, call the clock. So this function WASI get time, which is basically then calling the interface, the WASI interface clock time get. Can I run this in here? Yes, I think I can. So I will just run this here. No, I think this doesn't work. So I need to use the Gradle task. So we have WASM, so we can run it with WASM time. So here we have WASM, WASI, node production run. Let's call that. And now we're gonna, here we have no prime numbers, and there we found the current time, which is a prime, and the rhyme. And now also really cool technology. We have Kotlin notebooks with which you can create charts, you can import data, you can do data operations on this one. So here we have the isPrime function. You can have more code snippets. So here we have like one more. You can run that code here. There we have the isPrime function, but you can also type like, okay, isPrime 7. You can do charts and everything. I think this is really cool. So calling isPrime 7. Yes, true, it's a prime. So yeah, kind of cool. Kotlin notebooks. And also something that many people don't really know about. So if you're in the debugger, did I? Yeah, I think I hit the bell. So if you're in the debugger, so look at this main function. It has nothing. This module even doesn't have a dependency on the other modules. So I will just copy paste this code here to just show off what it can do. So we can actually debug this function. Now we are in the debugger, and this one only allows you to enter a single line expression, but you can actually evaluate expression, make it bigger. Here we go. And yeah, so here you can see it's actually running, and then evaluate. Now we have Kotlin running in the debugger. And what's really cool about this, so you can do functions, you can do data classes, so there's lots of things allowed. So I just, this is really cool. So, and also you can select Java if you really dare to. But okay, so that's the debugger. Let's stop the debugger. And that was basically all the different things that I wanted to show. But what's also really cool here is, so I actually have, so in the common module, you can see there's a common test. And as you can see, I have all these different folders here. Why is that? Because we have the prime test. And actually, when I try to compute the primes on JavaScript, it actually failed because it ran into a timeout. So I just said, OK, I'm going to use isJS true for the JavaScript targets. And for all the other ones, like WebAssembly, it just will call it anyway. So we're just going to skip the test. And what I think is really cool here is the tooling. So we're going to run the prime test here, select all the different things. So here you can see Android, iOS simulator, JavaScript. It's actually going to launch a browser. It's going to launch the macOS terminal application, running that. And here we go, running on many different platforms at the same time with a single unit test, which I think is amazing. So we're not going to count it, but I'm going to hit the bell anyway because it's just so nice. And oh my good, we are completely in time. That's amazing. I didn't expect that. OK, very cool. So basically, if this was way too fast for you, thankfully there's a recording, so you can just crunch it down by like 50% or something. And you can find the code there on GitHub/mreichelt/run Kotlin run. And with that, have a nice Kotlin.